Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing everything you need to know about circles in order to perform your best on the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet-delivered computer adaptive test, that is the PiCAT. More specifically, I'm going to break this video down into three parts. In the first part of this video, I'm going to discuss some formulas that you need to learn and memorize in order to be successful on these tests. After that, I'm going to work out some easy practice questions. And then finally, I'm going to work on some practice questions that should closely mirror what you'll see on the actual ASVAB and PiCAT. In order to get the most out of this video, I strongly encourage you to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB. And so in light of that, I want to encourage you to do two things. First, I would say go to my website, asvabapp.com, and download a copy of my free reference sheet. Work on learning and memorizing those formulas. And two, make an effort to work out all these problems with no calculator. One reason people don't perform well on this test is simply because they can't do this work by hand. So all that being said, let's go ahead and get started with today's video. As I just mentioned, I'm going to start today's video by quickly discussing the formulas you need to learn and memorize to answer these types of questions. And in total, there's going to be three of them. To find the area of a circle, you're always going to use this formula. Area equals pi r squared. And let me mention a few things about this formula. Since we're working everything out by hand, we're going to approximate pi using 3.14 or 22/7. All right. In addition, I want to mention that r refers to the radius of this circle. A radius is defined as the distance from the center point to the edge of the circle. So here's my center point, and here's the distance to the edge of the circle. That would be my radius. Again, radius is defined as the distance from the center point of the circle to the edge of the circle. As for finding the circumference of a circle, there are two formulas you need to know. Circumference can be found by doing pi times diameter, or circumference can be found by doing 2 times pi times radius. Okay? In case you haven't seen its definition in a long time, diameter is defined as the distance from one edge of the circle to the other edge of the circle and through the center point. So from here to here would be the diameter of this circle. All right, so one thing you want to take note of is the relationship between the diameter of a circle and the radius of a circle. And let me say this, a diameter is twice as long as a radius, and that is expressed algebraically right here. The diameter of a circle is twice as long as the radius of a circle. All right, finally, I just want to mention this. Circumference refers to the perimeter of a circle. So if you start here and you were to walk around this circle, the distance you walked around this circle would be its circumference, whereas area refers to the space enclosed by the circle. So I like to think about circumference as finding the perimeter of a circle. All right, so with those formulas in mind, as well as those properties in mind, let's go ahead and work on some very easy practice questions. At this point in the video, it's a good idea to pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As you can see, this first question says, if a circle has a radius of 5 centimeters, then what is its diameter? So we know we're dealing with a circle that has a radius, or r, of 5 centimeters. Well, just a few minutes ago, I described the relationship between the diameter and radius of a circle. Notably, I said the diameter of a circle is always twice as long as its radius, And algebraically, that looks like this. D equals 2r. Well, in this case, we know what r is. According to the problem, r was 5 centimeters. So we can go ahead and plug that into this formula. This becomes d equals 2 times 5. Of course, 2 times 5 is 10. So we know the diameter of this circle is 10 centimeters. Let me stress this. If you know the diameter of a circle, you can find out what its radius is using this formula right here. Likewise, if you know what the radius of a circle is, you can quickly find its diameter. That's going to be very important once we get to the challenging word problem. So again, if you know the diameter, you can quickly figure out what its radius is. If you know what the radius is, you can quickly figure out what its diameter is. All right, so that's that one. Number 2 says, if a circle has a diameter of 20 inches, then what is its radius? So in this case, we were told our circle has a diameter of 20 inches. Again, we have to understand that there is a relationship between the diameter and radius of a circle. Notably, the diameter of a circle is always twice as long as its radius, or d equals 2r. In this case, we know what d is, so in place of d in this formula, we'll go ahead and plug in 20. This becomes 20 equals 2r. If we divide both sides by 2, this will cross out here, leaving us with r on this side. 20 divided by 2 is 10, so we know r in this case is 10 inches. Again, it's important to realize that if you know your diameter, you can figure out what your radius is. Likewise, if you know what your radius is, you can quickly figure out what your diameter is. And we use this formula right here. Diameter equals to radius. All right, so that's that one. Number 3 says, find the area of a circle that has a radius of 5 inches. Use 3.14 for pi. So again, to find the area of a circle, we're going to use the formula area equals pi r squared. We know radius of this circle is 5 inches. So in place of r here, we'll go ahead and plug in 5. This becomes area equals pi 5 squared. What is 5 squared? 5 squared is 25. So this becomes pi times 25. And again, as I mentioned, we're going to be working out everything by hand. So we're either going to use 3.14 or 22/7 to approximate pi. More often than not, the question's going to tell you which of those to use. And in this case, it said to use 3.14 for pi. So in place of pi here, we're going to put in 3.14. So this becomes 3.14 times 25. And let's go ahead and work that off to the side. Again, we have 25 times 3.14. That is to say, we're multiplying a whole number, notably 25, by a decimal, notably 3.14. In order to make this math a little bit easier, one thing we can do is shift this decimal and 3.14 2 times to the right, such that this becomes 314 times 25 with no decimals. And once we work this out, we'll take those 2 decimals that we shifted to the right here, and we'll shift them back into the left. All right, so let's go ahead and work this out. 4 times 5 is 20, so drop down a 0, carry a 2. 5 times 1 is 5, plus 2 is 7. 5 times 3 is 15. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. Let's add these together now. 0 plus 0 is 0. 7 plus 8 is 15. Carry a 1. 5 plus 2 is 7, plus 1 is 8. And then 6 plus 1 is 7. Bring our 2 decimals back in. 1, 2. So the area of this circle is 78.5 inches. And of course, that's squared. Again, when you find the area of something, you're always going to have your units squared. When you find the volume of something, your units are always going to be cubed. All right, so that was a very simple example of finding an area of a circle when you know its radius. The most difficult part of this problem was doing the work with the decimals by hand over here. All right, so let's go ahead and move on. All right, so number 4 says find the area of a circle that has a radius of 7 inches. Use 22 over 7 for pi. We should know that we're going to be using this formula, area equals pi r squared. Thankfully enough, we know what the radius of our circle is. It's 7, so we'll go ahead and plug that in accordingly. And in this case, we're going to be using 22 over 7 to approximate pi. But let's hold off on that for just a second here. We have area equals, again, we're going to plug in pi in just a few minutes. We know r is 7 according to the problem, and that's squared. Area equals pi. What is 7 squared? 7 squared is the same thing as 7 times 7. 7 times 7 is 49. Let's go ahead and substitute 22 over 7 in for pi now. This becomes 22 over 7 times 49. All right, so as you can see, you always have to be able to work with fractions to be successful on the ASVAB. And in this case, we're working on multiplying 22 over 7 by 49. That is to say, we're multiplying a fraction by a whole number. And let's go ahead and work this off to the side. We have 22 over 7 times 49. One approach you can take to working this out very quickly is by doing this. I can express 49 as a fraction by placing it over 1. And that's going to enable me to do this. I can say 7 goes into 7 one time, 7 goes into 49 7 times. All right, and now we have 22 over 1 times 7 over 1. Well, what is 22 divided by 1? 22 divided by 1 is 22. Again, anything divided by 1 is just itself. What is 7 divided by 1? Well, 7 divided by 1 is just 7. So in other words, 22 over 7 times 49 reduces to 22 times 7. And of course, we can quickly work that off to the side. 22 times 7. 7 times 2 is 14. Drop down a 4, carry a 1. 7 times 2 is 14 plus 1 is 15. So this is 154. And our units were inches. So 154 inches squared is the area of this circle. All right, so again, you have to be able to work with fractions to be successful on the ASVAB. Once we get to the more challenging problems, you're going to see I included more fractions there too. All right, so that is that one. As we can see, number 5 says, find the circumference of a circle that has a diameter of 10 inches. Use 3.14 for pi. So in this case, we're finding the circumference of a circle. Again, there are two formulas we can use to do that. We can either use circumference equals pi times diameter, or we can use circumference equals 2 pi r. Well, in this case, we were given the diameter, so we know d in this case is 10. So let's go ahead and use this formula. We know circumference is going to be pi times, again, the problem told us d was 10, so this becomes pi times 10. And of course, it told us to approximate pi using 3.14, so this becomes 3.14 times 10. Now here's the beauty about multiplying a decimal by a power of 10. When you multiply a decimal by a power of 10, all you have to do is shift your decimal to the right according to how many zeros there are in that power of 10. Powers of 10, for example, are 10, 100, 1000, 10,000, and so on. Well, in 10, there's only one zero. So I'm just going to take this decimal in 3.14 and shift it one time to the right, and this becomes 31.4. In other words, 3.14 times 10 is 31.4. Of course, this is inches. And Now we can say the circumference of this circle is 31.4 inches. Again, this circumference is technically the perimeter of our circle, so it's not going to be squared. All right, so that's that one. Number 6 says, find the circumference of a circle that has a radius of 5 inches. Use 3.14 for pi. Again, we're finding circumference, so we can use either one of two formulas, notably circumference equals pi times diameter, or circumference equals 2 pi r. In this case, we were told our circle had a radius of 5 inches, so we know r is going to be 5. Given that we know what r is, I'm going to go ahead and use this formula over here. Let's go ahead and plug in 5 for r. This becomes circumference equals 2 pi times 5. We can multiply 2 times 5 before we go any further. 2 times 5 is 10, so the circumference is 10 pi. Now the problem told us to approximate pi using 3.14. This becomes 10 times 3.14. And we saw how to deal with this previously. Again, we're multiplying a power of 10 by a decimal, and all we have to do in light of that is shift our decimal to the right according to how many zeros there are in our power of 10. In 10, there's 1 0, so we're going to take our decimal and shift it one place to the right, and this is 31.4. Okay, so that is this one. The circumference of this circle is 31.4. And you may have noticed that this circle had a diameter of 10, whereas this circle had a radius of 5. In other words, these were the same exact circles. Okay? Now that we've worked out some very simple practice problems, let's take a look at some questions that should closely mirror what you'll actually see on the ASVAB or PiCAT. If you haven't been doing so, I strongly encourage you to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. All right, so this first question says, using 22/7 to approximate pi, find the area of a circle that has a diameter of 4/5 of a centimeter. Express your answer as a fraction. All right, so first things first, we know we're going to be finding the area of this circle, and there's only one formula we can use to find the area of a circle. Notably, area is equal to pi r squared, where r, of course, refers to the radius of a circle. All right, we have a little bit of a problem here. According to this problem, we know the diameter of this circle is 4/5 of a centimeter. That said, to find the area of this circle, we don't need its diameter, we need its radius. So again, we're going to have to fall back on the relationship between diameter and radius of a circle. Notably, diameter is always twice as long as the radius. So in place of d here, I can go ahead and plug in 4/5. This becomes 4/5 equals 2r. If we solve for r, we'll know what our radius is. So we're going to divide both sides by 2 now. This will cross out over here, leaving you with just r on this side. But that said, we have this left, 4/5 divided by 2. One thing you can do is you can rewrite 2 as a fraction by placing it over 1. And now this says 4/5 divided by 2 over 1. And let me pull this off to the side. We have 4/5 divided by 2 over 1. That is to say, we're dividing two fractions now. Well, how are we going to proceed? When you divide two fractions, you follow the algorithm keep, change, flip. That means you keep this top fraction as is, so that's going to be 4/5. You change from division to multiplication. So we went from division to multiplication, that's our change. And then you flip this second fraction. So instead of being 2 over 1, it's going to be 1 over 2. All right, so now we're just multiplying 4/5 by 1/2. When you multiply fractions, you just multiply straight across. So 4 times 1 is 4. 5 times 2 is 10. This becomes 4/10. And we can reduce this very quickly. You should notice that both 4 and 10 are divisible by a common factor of 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So we know our radius in this case is going to be 2/5. All right, so now that we figured out what our radius is, we can go ahead and plug it into our formula over here. This becomes area equals pi, and radius is 2/5 squared. All right, so let's go ahead and work this out. 2/5 squared. How are we going to deal with that? Well, whenever you have a fraction squared like this, it becomes this. Okay, we have 2/5 squared. This square is going to be applied to each of these separately. So I like to think about this one like this. 2 squared over 5 squared. 2 squared is 4. 5 squared is 25. So this becomes pi times 4 over 25. Of course, we were told to use 22 over 7 to approximate pi. So we know pi is going to be 22 over 7 times 4 over 25. And now we're just multiplying two fractions again. So we're going to multiply straight across. That is to say, this is going to become 22 times 4 over 7 times 25. Let me go ahead and scroll down a little bit. If you can't do this mentally, you could always do it off to the side. 22 times 4. 2 times 4 is 8. 2 times 4 is 8. So this becomes 88 over, what is 7 times 25? Again, if you can't do that mentally, you can always work it off to the side like this. My pen's starting to act up on this one. 7 times 5 is 35, so bring down a 5, carry a 3. 7 times 2 is 14, 15, 16, 17. So this is 88 over 175. Of course, this is going to be centimeters squared. And the problem said leave your answer as a fraction. And I do not believe we can reduce this. So our answer to this one is its area is 88 over 175 centimeters squared. All right, so as you can see, I can quickly throw in a lot of simple things into a word problem to make it much more challenging than what we've seen so far. As a matter of fact, first I tested your knowledge of knowing the formula to find the area of a circle. After that, I tested your knowledge of the relationship between diameter and radius. In the middle of that, you had to know how to divide fractions and multiply fractions. Okay, so this is a very typical question that you may see on the ASVAB or PiCAT. You can't escape working with fractions. You have to know how to work with fractions. In addition, you have to memorize these formulas, and you also have to know the relationship between diameter and radius of a circle. So again, that's a very challenging problem, but it's representative of what may show up on the actual test. All right, so that's that one. All right, so number 2 says, if the area of a circle is 36 pi, then what is its radius? All right, so we know we're working with the area of a circle, so let's write down that formula. Area equals pi r squared. In this case, we were told that the area of this circle is 36 pi, and we want to figure out what its radius, or r, is. So in place of a, I'm going to go ahead and plug in 36 pi. This becomes 36 pi equals pi r squared. And again, we're trying to figure out what its radius, or r, is. So we're going to be solving for r in this case. So let's start by dividing both sides by pi. This crosses out here, leaving you with just r squared on this side. These two pi's cross out over here, leaving you with just 36 on this side. To get rid of this square, we're going to take the square root of both sides. This will cross out this square, leaving you with just r here. The square root of 36 is just 6, so we can see r in this case is 6. And we weren't given a unit, so we're just going to say the radius is 6. All right, so number 3 says the diameter of the wheel on a bus is 1 foot. How much distance will the bus cover in 100 rotations of the wheel? use 3.14 for pi. All right, so for this problem, you have to understand that there is a relationship between the circumference of a circle and the distance a wheel travels on the ground. And let me go ahead and try to explain that for you. So let's say we had this circle here. Let me draw a better circle. Let's say we had this circle here. And let's imagine I tied a string around this circle so it's snug all the way around. Well, what if I cut that string and then laid it out flat on the ground, like so? What that would tell you is the circumference of the circle is the same distance that the wheel travels upon one rotation. Again, the circumference of a circle is the same distance that a wheel travels upon one rotation. And again, if it's helpful, think about tying a string around a circle, cutting that string, and then laying that string flat across the ground. All right, so for this one, we're going to start by finding the circumference of this wheel. We know this wheel has a diameter of 1 foot. And again, there are two formulas to find the circumference of a circle, notably 2 pi r as well as pi times diameter. Since we were given diameter, we're going to use pi times diameter in this case. And of course, we're going to take 1 and plug it in for d. So this becomes circumference equals pi times 1. And of course, we were told to use 3.14 to approximate pi, so let's plug that in as well. Anything times 1 is itself, so 3.14 times 1 is 3.14. So we know that this bus wheel has a circumference of 3.14. That means that upon one rotation, it goes 3.14 feet across the ground. In order to figure out how much ground it covers upon 100 rotations, we're going to take 3.14 and we're going to multiply that by 100. All right. And this math, as it turns out, is very easy to do. As you can see, we're multiplying 3.14 by a power of 10, notably 100. As I mentioned in this video previously, when you multiply a decimal by a power of 10, such as 10, 100, 1000, 10,000, and so on, you just take that decimal and you shift it to the right according to how many zeros there are in your power of 10. Well, in 100, there are 2 zeros. So we're going to take 3.14, we're going to shift it 2 times to the right, and our decimal's right here. So this becomes 314. In other words, if this wheel on the bus that has a diameter of 1 foot is rotated 100 times, that means that the bus will have traveled a total distance of 314 feet. All right, so number 4 says the area of one circle is 4 times as large as a smaller circle. If the smaller circle has a radius of 3 inches, then what is the radius of the larger circle? So at first glance, this problem seems pretty challenging, and it is. That said, at the end of the day, we're just comparing two circles with each other. In addition, we know that this small circle has a radius of 3 inches, and we want to know what the radius of this large circle is. Again, this large circle has 4 times the area of this small circle. So the first thing I want to do is figure out what the area of this smaller circle is. And again, to find the area of a circle, it's pi r squared. We know the radius of this small circle is 3, so this becomes area equals pi 3 squared. 3 squared is 9, so the area of this small circle is 9 pi. Again, if the area of this small circle is 9 pi, that means that the area of this big circle is going to be 4 times 9 pi. What is 4 times 9? 4 times 9, of course, is 36. So the area of this big circle here is 36 pi. And we saw previously that if we know the area of a circle, we can find its radius. Again, the area of this big circle would be pi r squared. We know that this big circle has an area of 36 pi. So in place of a here, I'm going to put 36 pi equals pi r squared. Let's divide, as we did previously, both sides by pi now. This crosses out, leaving you with r squared over here. These cross out as well, leaving you with 36. To get rid of this square, we'll take the square root of both sides. This will cross out this square, leaving you with r on this side. The square root of 36 is 6, so r in this case is 6, and that's going to be inches. All right, so the radius of our larger circle, as you can see, is 6 inches. All right, so that's that one. Somewhat of a challenging problem, but you may have noticed that to solve these more challenging problems, we're using all the smaller pieces that we worked out from the easy problems. All right, so number 5, which is a question I got from one of my free practice tests on my website, says this: what is the area of the shaded section of the figure below? The circles are identical and have a radius of 5 inches. In addition, they're inscribed by a rectangle. Use 3.14 for pi. All right, so again, we're trying to figure out what the area of this shaded section below is. And it should be pretty obvious that to find the area of the shaded section, we're first going to find the area of our rectangle. And from that, we're going to subtract the area of one of these circles, and I'm going to call that area of circle 1, as well as the area of our other circle, which I'm going to call area of circle 2. Now, since these circles are identical, we can actually just write this like this: area of our rectangle minus 2 times the area of circle 1. Again, circle 1 and circle 2 are identical, therefore their areas are the same. All right. Now, how do we find the area of a rectangle? Of course, that's length times width. And how do we find the area of a circle? We should know by now that that's pi r squared. All right. Again, according to the problem, we know what the radius of one of our circles is. It's right here. It's 5. So let's go ahead and plug that in. This becomes length times width minus 2 times pi 5 squared. Let's go ahead and work this out very quickly. This becomes length times width minus 2 times, what is 5 squared? 5 squared is 25, so this becomes 25 pi. And what is 2 times 25 pi? Well, that's going to be 50 pi. All right, so clearly we've worked this out as much as we can, and now we've hit a little bit of a roadblock insofar as we don't know what the length or width of this rectangle is. That said, using our knowledge of the definition of what a radius is, we can quickly figure out what L and W are. Again, as I said in this video, radius is defined as the distance from the center point of the circle to the edge of the circle. So from here to here is a radius. And according to the problem, we know this circle has a radius of 5. And from here to here is another radius. Again, according to the problem, we know that that is 5. Clearly, this is the same as the width of this rectangle. So we know width is going to be 5 plus 5 or 10. Again, using our definition of what a radius is, we can also find what the length of this rectangle is, because from here to here is a radius. We know that's 5. If we put our center point down, we know from here to here is 5, and from here to here is 5. So from here all the way to here is the same distance as the length of our rectangle. So that's going to be 5 plus 5, 10, plus 5, 15, plus 5, 20. All right, so this becomes 20 times 10 minus 50 pi. 20 times 10 and that's 50 pi. 20 times 10 is going to be 200 minus 50 pi. Now we have to figure out what 50 pi is. Again, according to the problem, we're going to approximate pi with 3.14, so this becomes 200 minus 50 times 3.14. And I'm going to work that off to the side so as not to make any mistakes. We have 50 times 3.14. So what we want to do is take this decimal in 3.14 and shift it 2 times to the right, such that this becomes 314 times 50. And once we work this out, we're going to take our 2 decimals that we moved to the right here and shift them back into the left. So let's work this out. 4 times 0 is 0, 1 times 0 is 0, 3 times 0 is 0. Before we start multiplication with that 5, we have to bring in a 0 placeholder. 5 times 4 is 20, so bring down a 0 and carry a 2. 5 times 1 is 5, plus 2 is 7, and 5 times 3 is 15. Let's add these together. 0 plus 0 is 0. 0 plus 0 is 0. 7 plus 0 is 7. 5 plus nothing is 5. 1 plus nothing is 1. Let's bring our 2 decimals back in. 1, 2. So this becomes 200 minus 157. And if you can't do that in your head, let's go ahead and work that off to the side as well. We have 200 minus 157. 0 minus 7 we can't do, so we have to look to the left to borrow. Can't borrow from a 0, so we're going to have to borrow all the way from this 2. This is going to become 1. This will become 10. Borrow one more time. This will become 9, and this will become 10. 10 minus 7 is 3. 9 minus 5 is 4. 1 minus 1 is nothing. So this is 43 inches squared. In other words, the area of the shaded section of this figure is 43 inches squared. All right, so that's a challenging problem. But that said, again, if you use your knowledge of some basic principles of circles as well as rectangles, this problem was pretty simple and straightforward. All right, so that is that one. All right, so number 6 here says the circumference of a bicycle wheel is 50.24 inches. What is its diameter? Use 3.14 for pi. All right, so again, we're given the circumference of this wheel, so we know we're going to be working with the circumference formula. We want to know what its diameter is. So of the 2 formulas to find the circumference of a circle, we're going to use pi times diameter. This problem told us what C was. It said circumference, or C, is 50/24. So in place of C in our formula here, I'm going to put 50/24. So this becomes 50/24 equals, what is pi? We're told to use 3.14 for pi, and that's times d for diameter. We're trying to solve for diameter. So what we want to do now is get d by itself by dividing both sides by 3.14. This will cross out over here, leaving you with just d on this side. And as you can see, d is 50/24 divided by 3.14. In other words, by doing 50.24 divided by 3.14, we'll know what the diameter of this bicycle wheel is. And in case you haven't worked with decimals in a long time, we can go ahead and write this first like this. This says 50/24 divided by 3.14. When you're dividing decimals like this, you can't have a decimal outside the division bracket. So what we have to do is we have to take this decimal in 3.14 and shift it 2 times to make 3.14 314. And at the same time, we're going to take this decimal inside the division bracket and shift it 2 times as well to make it 5,024. All right, so now that we cleared the decimal from outside the division bracket, we can go ahead and proceed as we normally would. We start by asking ourselves, how many times does 314 go into 5? It doesn't. How many times does 314 go into 50? It doesn't. How many times does 314 go into 502 without going over? Well, that's going to be one time. Again, if this was 300 times 2, that would be 600, which is too big. All right, so we know it's 1. 314 times 1 is 314. Let's go ahead and perform this subtraction now. 2 minus 4 we can't do, so we're going to have to borrow. We have a 0 here, so we can't borrow there. We're going to have to borrow from this 5. This will become 4. This will become 10. We're going to borrow one more time. This will become 9, and this will become 12. 12 minus 4 is 8. 9 minus 1 is 8. And 4 minus 3 is 1. Now, of course, we got to drop down this 4. And the question is this. How many times does 314 go into 1884 without going over? Well, let's use some estimation here. If this was 300 and this was 1800, I would say 300 times 6 would be 1800. So I'm going to say 314 is going to go into 1884 about 6 times. And before I write that 6 here, I'm going to work this off to the side to confirm it. We have 314. We're multiplying that by 6. 4 times 6 is 24, so drop down a 4, carry a 2. 1 times 6 is 6, plus 2 is 8. And 3 times 6 is 18. So 314 times 6 is 1884, and there's no remainder. So the diameter of this circle that has a circumference of 5024 is going to be 16. And in math, we write the variable for which we solved on the left. So this is going to be d equals 16 inches. All right, so again, in this video, you've had to work with decimals as well as fractions. There's no escaping that on the ASVAB. All right, so number 7 says a semicircle shaped rug has a diameter of 2 feet. What is the area of the rug? Use 3.14 for pi. All right, so in this video, I've discussed how to find the area of circles. And we know that's area equals pi r squared. In this case, we're working with a semicircle. And a semicircle is just a circle that's been cut right in half. And as you can imagine, to find the area of a semicircle, we're going to take the area of a circle, which is pi r squared, and we're going to multiply that by 1/2. So in other words, we're going to be finding the area of this half of this circle, for instance. What's more, we know that the diameter of our rug is 2 feet in this case. So from here to here is 2 feet. Well, as you can see, we need to know what the radius of our rug is in order to find its area. So we're going to fall back to this relationship. The diameter of a circle is always twice its radius. We know that the diameter of our semicircle is 2 feet. So that's 2 equals 2r. If we divide both sides by 2, we can get r by itself. This crosses out there, leaving you with r. 2 divided by 2 is 1. So the radius of our semicircle is 1. So now that we know what r is, we can go ahead and plug it in accordingly. This becomes 1/2. Again, pi is going to be 3.14. And this is going to be r of 1 squared. 1 squared is the same thing as 1 times 1, so that's just 1. So this becomes 1/2 equals, or 1/2 times 3.14. 1 squared is just 1. Again, anything times 1 is just itself, so 3.14 times 1 is just 3.14. So this becomes 1/2 times 3.14. All right, so there are 2 approaches you can take to solving this. I've worked with circles so much that I know the answer is going to be 1.57. Again, half of 3.14 is 1.57. That said, if I was working this out on my own, I would do this. I would know 1/2 is the decimal equivalent of 0.5. So this would be 0.5 times 3.14. And then I would work this off to the side like this. 3.14 times 0.5. And now we got to clear these decimals. I got to move the decimal place 1 2 times here, and 1 time here. So in total, I moved the decimal place 3 times to make this 314 times 5. Once I work this out without decimals, I'm going to take my decimal place and move it 3 times to the left. All right, so 4 times 5 is 20. Carry a 2. 5 times 1 is 5 plus 2 is 7. And 3 times 5 is 15. Bring our 3 decimals back in. 1, 2, 3. So we can see that 0.5 times 3.14 is going to be 1.57. So the area of our semicircle is 1.57, and this is going to be feet squared. All right, so that is that one. All right, so that is it for today's video. As usual, I hope you found it helpful, and as always, you're more than welcome to leave feedback in the comments section below. I want to encourage you to go to my website and download a copy of my reference sheet if you haven't done so already. Again, my reference sheet is 18 pages long, and it has everything you need to know to do well on either the ASVAB or PiCAT. Please work on learning and memorizing those formulas. If you want to help my channel out, please consider subscribing to it. And on that note, I'm going to go ahead and cut you loose. こんにちは。